So have you ever stopped to think about what happens in that first, tiny fraction of a second when your phone grabs a 5G signal? It's not just a simple hello. It's actually a super complex, incredibly fast dance that sets the stage for everything else. All right, let's pull back the curtain on this invisible handshake and see exactly how 5G pulls it off.
And that brings us to the core puzzle, right? We all know 5G is built for speed and handling tons of devices. But that creates a brand new problem right at the very beginning. How does your one phone manage to get the network's attention and start a conversation when it's surrounded by a massive crowd of other signals?
The easiest way to get your head around this is with an analogy. 4G was kind of like shouting in a big room with a megaphone. One big, loud signal goes out everywhere and everyone can hear it. Simple, yeah, but not very efficient. Now 5G, that's totally different. It's like using dozens of laser-focused spotlights. It's way more precise, but it brings up a huge question. How does the network know exactly where to point its spotlight to find you?
Well, the answer to that problem lies in a process that's fundamental to all cellular networks, but one that 5G has completely supercharged. It's called RACH, which is short for the Random Access Channel. This is that digital handshake we've been talking about.
So what is RACH? In the simplest terms, it's the official standardized way for your phone to basically raise its hand and say, hey, I'm over here and I'd like to get online. It is the very first conversation your phone has with the network. At its heart, this whole handshake is a four-step dance, and that's true for both 4G and 5G. It's this little back and forth. Your phone sends a hello, called a preamble. The network shoots back with some instructions. Your phone sends its official request, and then the network gives the final, you're in. So if the basic steps are the same, what makes 5G so different?
Well, this is where it gets really interesting. The differences might seem subtle, but they are incredibly powerful, and they're all about solving that spotlight problem we mentioned earlier.
Now take a look at this table. The real game changer is right there in that first row. In 5G, RACH isn't just about getting access anymore. It has a crucial new job, beam management. That right there is the secret sauce. You can also see 5G cleans things up a bit, putting all the instructions in one place, what's called SIB1, and it introduces new, faster ways to say hello, which we're going to get to right now.
And that new job, that whole beam management thing, that leads us to the absolute magic trick behind 5G's efficiency. It's a really clever concept called beam correspondence.
Right, so let's circle back to that big question. You've got all these spotlights, all these beams, sweeping around. How in the world does the network instantly know which one to lock onto you with to get that connection going? And here is the incredibly clever answer: beam correspondence. It's basically a system where the network pre-assigns a specific resource, like a very particular time slot or a unique hello code, to each one of its individual beams. Think of it like color-coding the spotlights and giving you the matching colored key. Okay, so here's how it all goes down in a blink of an eye. Your phone is always listening, right? It's constantly measuring the strength of all the different 5G beams it can detect. And in a split second, it figures out which one is the strongest, which is its best shot at a great connection. Now, this is the genius part. Your phone doesn't just shout its hello out whenever it feels like it. No, it very deliberately uses the exact RACH resource, that specific time slot or code that the network already assigned to the beam it just found was the strongest. And boom, that's the magic trick. The network doesn't have to hunt for you. It doesn't have to guess. Just by seeing which resource your phone used to say hello, it instantly knows which of its many beams is already pointing right at you. The choice of the resource is the message. It's brilliant.
Okay, but 5G has to work everywhere. It's not just for one specific place. It needs to work in a packed city and out in a wide open field. So this handshake can't be a one-size-fits-all kind of deal. It needs different tools for different situations.
And to do that, it needs a couple of different tools in its toolkit. This is where those different preamble formats we mentioned come into play. Remember, the preamble is just that first hello signal. And 5G has two main flavors: long preambles, which are kind of like the old 4G style, and brand new short preambles, which are totally built for the modern 5G world. First up, you've got your long preambles. Think of these as the long-distance runners. They take a little bit longer to send, which lets the signal travel much further. This makes them absolutely perfect for those wide-open suburban or rural areas where cell towers are spread far apart and need to cover a lot of ground.
And then you've got the short preambles. These guys are the sprinters. They are all about speed and flexibility. They're transmitted incredibly fast using these super compact signals.
That makes them perfect for crowded cities with tons of users, and they are absolutely essential for making that super high-frequency millimeter wave 5G work at all.
All right, so we've gotten kind of deep in the weeds here, beams, preambles, all that stuff. But let's pull back for a second. Why should you even care about how this initial handshake works? Why does it really matter?
This quote from the source material really just hits the nail on the head. If the network didn't know which beam you were on, it would have to just blast everything out on all of its beams all the time, just hoping you'd hear it. And that, as it says, is a colossal waste of resources.
And that brings us to the real payoff. By figuring out exactly where you are from the very first moment, the network becomes massively more efficient. It saves a ton of energy. It cuts down on network congestion because signals aren't just splashing around and interfering with each other. The handshake itself gets done way faster. And maybe most important of all, it lays the foundation for all that speed. Once the network knows exactly which beam to use, bam, it can start pumping high-speed data to you on that beam with zero delay. So you see, that first hello, that invisible handshake, it isn't just a formality. It's the secret engine that makes 5G so incredibly smart and efficient. It's the clever foundation that everything else is built on. It really just leaves you wondering, with a connection this intelligent right from the start, what are we going to build on top of it next?